According to the Centers for Disease Control (CDC), heart disease is the leading cause of death across the US, and a prominent heart disease is heart failure. So what is heart failure? Heart failure is a clinical syndrome which is often caused by structural abnormality in which the heart cannot pump enough blood to meet the body's needs. This lack of blood supply leads to retention of fluid or congestion across the chest. Believe me, there are a number of Americans who are affected with heart failure. In fact, according to American Heart Association, there are nearly 6.5 million Americans over the age of 20 that have heart failure. And if this goes on and necessary interventions are not taken, then it is projected to grow to 16.1 million US adults by 2030. Moreover, heart failure leads to several other severe diseases, for example, lung and heart diseases and even heart attack. Therefore, it is inevitable to have a device that can prevent heart failure. Imagine how good it will be to have a wearable device that can predict heart failure days before it actually happens. My research project aims to build such a wearable sensor that has the potential to not only to predict a heart failure but can provide enough time to prevent it. Literature actually shows that if important parameters are sensed in a timely manner, then heart failure can be predicted 14 days before it occurs. These important parameters include thoracic impedance, which is a measure of the resistance in the thorax region. Other parameters include heart rate, ECG, which is the electrical representation of the heart performance, and the level of oxygen in the blood. For your reference, thorax region is defined as a region between the neck and the lower rib of the human body. Project involves three major steps. First step involves the extraction of these parameters from the sensor. Second step involves the development of the algorithm using artificial intelligence. And the third step involves the integration of these sensors. As far as the AI-based algorithm is concerned, it assesses an individual's risk to heart failure and provides an alert whenever the results exceed the specific threshold. For the better understanding of the algorithm, consider when we apply it on thoracic impedance sensor data. Thoracic impedance sensor will give us real-time values of the resistance of the thorax region. And as I have discussed, that before a heart failure occurs, fluid starts to retain in the thorax region. This retention of the fluid in the thorax region will decrease the thoracic impedance. An algorithm can keep a track of this decrease in thoracic impedance, and whenever it falls below a safe threshold, which is on average is 75 ohms, it will provide an alert not just to the user but also to his concerned medical officer for him to make necessary interventions. The final step will be to integrate these sensors on a comfortable wearable belt that one can wear and carry anywhere and at any time. With it, I conclude that we all keep our heart healthy so as we won't stay apart. Thank you.